Hello everyone. Today is the 23rd day of Leetcode 75 challenge. Let's begin with the 23rd question. Question 2352, equal row and column pairs. The level of the problem is medium. I will request you to read the question beforehand as I will deep dive into the PPT and explain it in simpler way. Now let's understand the problem in easiest way possible. So you are given a square matrix of size n cross n and you need to count how many pairs of row and column are exactly the same. A pair is defined as R of I and C of j, where R of I is the row ith column or ith row, sorry, and Cj is the jth column. Fine, and the row and column considered equal if all elements at each position are in same order. Fine. For example, if row has, for example, if this is the grid of n cross n size, and if this is 1, 2, 3, one row, so then one of the column should also have the same value, right? And you need to check every row against every column. For example, if you're taking this row, you have to check it against all the columns, fine. Then again, if you're taking the second row, then you have to check it against all the columns again, fine. For each matching pair, we increase the count, fine. And after checking all combination, we return the total count of matching rows, column pairs, fine. The question is very simple and to the point that you have to check for the same column and rows in a given grid, and you will just increase the count for that and return it at the end, fine. So let's understand the constraints now. Constraint is grid length is from n to grid of I of length, and n goes from 1 to 200, and grid of I of j could go from 1 to 10 to the power 5. Now let's move to the next slide. Let us understand the input output of the problem. So output for this is 1, fine. So if you can see here, we have 321 in the row 176 and 276 or 277, fine. If you can check, this 277 is row, fine, and this 277 is another row, fine. Any other matching rows are there? There is no 176 here, and there is no 321 in the column side, right? So the output becomes 1. And similarly here, if you could check, we have 3122, 1445, and 2422 and 2422, fine. And these two rows are same, fine. If you check here, 3122, fine. If you can see, 3122 is same as 3122, fine. So count becomes 1. Again, if you go and check for 3122 in other columns, you don't get that value, fine. Now for 1445 row, if you go and check in the columns, you will not find any 1445 array, you can say, in the column section, fine. If 2422 is there, right, and in the column, if you check this column, 2422 is same as this row, fine. So you increase the count to 2. Then you check there are no more column matching to this row. Then you come to this row 2422 and you check that again this row comes out to be similar, or you can say same. So you increase the count by 1 and becomes 3, and output is 3. So this is the problem output explanation. I hope you understood this explanation. It's pretty easy. It is straightforward. Okay. Now let's move to the next slide. To understand what problem is asking, we should build up an intuition to the problem. Fine. So let's imagine by taking an example of by managing a square grid in example puzzle game. So each row is a sequence of moves by a player, and each column is a sequence of moves from a different angle. So task find out how many rows look exactly the same. They have the same value and same order. No rearranging or skipping of values are allowed. Just pure one-to-one matches. Fine. This is what our intuition tells us to do. But again, example, right? So if we see in a straightforward manner, which comes to our mind, if we go through the grid, let it be this values 1 0 1 2 0 1 2, okay, and uh, 1 2 3. Let me put here 1 2 3 and put some random values here. So here only one row and one columns are matching. You can see here, fine. So what comes to our mind is that we will stand in every row and we will check for every column, fine. Suppose you're standing in this row, then you're checking for the zeroth column, fine. Then you go the second column, you check for the zeroth row, you are checking for this first column. Then again for the zeroth row, you are checking for the second column. Fine. Then again you start in the first row and you again check for zeroth column, first column, second column. Similarly for the third row, the second row, you go for the zeroth column, first column and second column. And this is the thing which we can do. Now how we will do that? We know how to iterate in a grid, okay, using two for loops. Now there will be another for loop which will have a condition grid of row of I and grid of I of C. Fine. This is row, this is column. Fine. Now we know that this is a thing which we can do, right? This is the first thing which comes to our mind, and it is totally correct. It's not wrong. And this condition will help us to solve it. So this basically says that when you are row zero, since the third for loop will basically go from I to n. Fine. And there you will say row zero. Basically, I'm standing in row zero, and I is this for loop I, which is zero right now. Fine. So I'm standing here. Then if this I increases from 0 to 1, row is same, you come in the second column value. Then it becomes 2, then you come in the third column value. So this grid of R of I basically says that you are iterating a column. And here, if you check I is 0 and C is also 0 right now. So I'm standing here. Now I increases to 1. What happens? Now you're standing in 0th column itself, but you're coming to the second row. Fine. Then it becomes 2, then you're coming to the third row. Basically, you're iterating a column. Understood? Now, why we are using this? We will be using these two things simultaneously in putting condition. If they are not equal, we will break out. Because if they are equal, fine. If you came here, equal, fine. You came in the third part, it's not equal, reject it, fine. Then column comes to the second columns comes to the second part, fine. Here, the second column. Again, you start checking with the zeroth row and first column. Then again, column comes to the third with the first row and third column comparison is done. After that, the second for loop is also done. Then you come to the ith for loop, which is the row for loop. Fine. Now we are in the first row, second row, we would say, and first column. Fine. Again it starts. Again you check this conditions. You can see here this is not equal to this. Fine. This row is not equal to this. So you move ahead. You come here. You can see that this part is matching this. Great. Again you come here. This part matches this part. Then you come here and you come here. This part matches this part. So you count increases to plus plus. Fine. So this is the basic thing which comes to our mind, and yeah, this will surely give us a solution. But there is an issue. Issue is for every row we are checking against every column. Fine. So grid of row comma 0 and grid of OC or I of C takes another n time complexity. Now already we were solving this in O of n square solution by iterating the grid. Now again you are iterating n times to check for the equality of the values in rows and column. So it becomes O of n cube. Fine. So it is way too big or slow for the big. So if basically if grid is of suppose 100 into 100, it will of course get submitted, but it will take a lot of time to resolve this grid. Fine. So what we can what optimized solution comes to our mind is that we know that these are the rows, but if we know that this there are only 4 rows, and if we have this row value, suppose this row value, I will go in every columns and check if there is any column similar to this row. Fine. Then again we will come to this row and we will again check the same thing for the columns. Now what if we store these columns? Sorry, these rows in a key value pair type, like row one and row two, row three, right? But if we store it in this way and the count also. Now why count? Suppose this row and this row are same, fine, and you got one column. This column is similar to this row, and this row is also similar to this column. Basically, this, so how much it will be? Count will be For this row and this column, count will be 1. Again for this row, this column, count will be 1. So becomes 2. So to further optimize that also, in the starting, if we just store the count of the rows, like this rows appears 2 times, right? So then when we will be iterating through the columns, and when we will get this common row, we will be knowing, okay, in dictionary for this row we have 2 count. Basically, this appears 2 times, so it will be compared 2 times. So directly we will enter no increment 2 in our count. So this makes us more optimized. We don't have to iterate again and again for the same column. Fine. So this is the thing. And one more thing. In dictionary, we cannot store directly the array. Keep that in mind, or the list as a key. We have to convert it to tuple because it uses hashing and key has to be immutable. Fine. It cannot be a mutable thing. That's why we cannot use array or list. So if you can see here, store how many times each row pattern appears in a key value pair. Now flip the grid column as tuples. For each column, we form a tuple and now check does this tuple exist in the map of rows or patterns. If yes, we add the count from the map to the total answer. This literally optimizes the solution a lot, to a lot of extent, right? I hope you understood this. Let me clear it once again. So what we are doing, we are just having the grid here, fine. So we are storing row 1, row 2, row 3, and its count. How many times this row appeared 1 time, this appeared 2 times, this appeared 3 times, fine. So we stored this in one iteration. So it took of n square, supposedly, fine. Then you do one more iteration where you just go for the columns, not the rows, fine. You just take columns and you just store the you just create a tuple of it, and then you check in the dictionary whether this exists in the dictionary or not. If not, no worries, we move ahead. Then again, we go and check whether this row exists or not. If it exists, suppose this row exists, okay, it appears 2 times in row, so we will increment the count by 2 because, as I explained earlier, if there are 2 rows and if you have taken the brute force approach, we would have counted it 2 times, right? So directly we know that there are 2 rows of the same value, so we will increment it by 2. Then similarly, the got this row appears to be 3 times here, for example, so it get incremented here. Fine. So I hope you understood the intuition how we are using dictionary here and why we are converting array to tuples and why we are storing tuple instead of arrays, and how this brute force approach, or this is also correct approach, but it is a less optimized approach since we are using NQ solution. How we are using this condition here, grid of R of I and I of C, to check the equality, and how we optimized here by using a hashing or hash technique of using dictionary. Fine. So I think this is pretty much clear. Now let's go to the next slide. Before going to the approach, let's understand what is dictionary data structure in Python. Fine. Dictionary in Python. A dictionary, also known as is a built-in data structure in Python that store key value pairs. The key is always unique, and it allows fast retrievals, insertions, and deletion of data using keys. Fine. What are the properties of it? Stores data as key value pairs, like X has the count 2 or whatever the value of it is there. Then no duplicate keys are there. Keys must be immutable. It cannot be changed. Fine. Values can be of any data type, and it is accessible in typically of O of 1 average time due to the use of hashing in it. Fine. And why is it efficient? Fast lookup. On average time, we can just check the key in O of 1 time. Easy to store and update the data structure, right? Like if you just say here, D is a dictionary. If you write here key equals to some value, so it gets updated, right? And highly optimized for associative data mapping, like counting the occurrences, grouping the data, mapping keys to values. Whenever you have to map something with something, like you have to store something about X, so you can use dictionary so that, okay, we know the value is X, and whatever the related information with it is stored, it could be stored in value, right? Also, there are operations to it, multiple operations of dictionary. I've written here, I've written the table here. So one is add and update. You can just add and update in this way, correct? Then accessing using the dictionary key, you can return the value of the given key. Safe access could also be done using this is a safe action. This means they're returning a value or default if it is not found. Basically, in this case, if the value is not there, it will return some error or some garbage value, right? But in this case, you're putting default here that if you don't have the key, just return something other than the value, right? Remove, we just write del and the key there. That signified specified key. And similarly for safe also, it is something like that only. Accessing the keys, accessing the values. If you are using items, then in for loop, if you just write key value, like in for loop, if you write for key value in d dot items, so you could directly get items and values or keys and values through iteration. Right? Checking existence if key is present in the dictionary or not, and look over items the way the one I described right now. This is the thing, right? So these are the most commonly used operations of dictionary, and this is enough operations to understand to complete all the data structures questions related to the dictionary. I hope you understood what is dictionary data structure and how it is used and what are the efficiency and key properties of it. Now let's move to the next slide. Now since we got the intuition of the problem, let's look into the approach how we're going to solve it. Fine. So we create an empty dictionary map to store row patterns and their frequencies. Fine. Get the row number, get the number of rows, columns using length of grid. Right. Since we need the length, what is the length, right? So we store it in n. Initialize the counter count to keep track of valid row column pairs. We need count variable to store the counts. Fine. These are two things. Now, what would be our third step? Second step. Second step would be store all the rows as tuple patterns in the map. So what we do, we iterate through the row, right? We create just tell it a list. Let it be list. We convert it to tuple, and from a grid of I to n, go till n. Basically, if this is the grid of I, grid of 0, I'm taking the complete value, complete row from 0 to n, and I'm storing it into a tuple format in the list variable. Fine. Then I'm putting that list in a dictionary with row with some values in there, and I increment the count by 1. Similarly, I do with the second row, third row. Fine. So here we are storing the rows in the dictionary. If array already exists in, so this convert the row into tuple. And if array already exists, we increment the count. Otherwise, we set count to 1 because it appears first time. The tuples are used because lists can't be dictionary keys. Fine. They are mutable. This helps store how many times each row pattern appears. Since tuples are immutable, we have to use tuples here. Fine. Now in the third step, we match each column with row patterns. Now we have the rows. Fine. In one iteration, we did the storing of rows and their count. Fine. Let this be the dictionary. Now we create a loop through each column j in the grid. Now we will iterate through the columns itself. First column, second column, third column. Fine. So we create an empty list array to hold the column values. So we create a list array, or you could say array or list. We store this complete value of first column in the list. Fine. Loop through each row of I and append grid of I and j to the array. Basically, iterate through this column, and we are putting this value in the list we created. We convert this list to tuple after one iteration of the column, right? And we check in the map whether this value or this key exists in the dictionary or not. If yes, we directly take the value from the map or dictionary like this way, array of key, and increment it, right? This means the current column matches this map of array of key and what's the number of rows. Fine. So here we can understand in first iteration, we just store the row values in key value pattern. Fine. And in the second iteration, or in step 3, we just iterated only through the columns, not the rows, only the columns, and we store the values. Fine. And check in the map whether they exist. If exist, we incremented the count. Now after processing all the columns, we return the final count at the end. Fine. The approach is also very straightforward. There's nothing to worry about. How hashing dictionary and tuple is helping us here, right? Efficient lookup. Using a dictionary for rows, avoid nested row column comparisons, which we were doing, which extra for loop which we were using, which were taking total complexity of O of n q. Instead of comparing element by element, to match whole row and column signatures. Fine. So what we did, we directly store the row values, and when we iterated the column, we directly check whether it is in the map or not. It helps in clean comparison. Tuples allow easy hashing and direct match checks because tuples helps to store the keys in the dictionary and reduces the time complexity to O of n square. Now let's move to the next slide. The code is the exact copy of the approach discussed. Let's understand it line by line. So we created a map, a variable map, which is basically a dictionary. We took the length of the grid. We created a count variable. Now, if you can see here we are creating key value pairs. Fine. I'm iterating through every row. We are taking the complete row value. If it is in the map already, we increment the count. Otherwise, we store it as count one. Fine. Now we increment only the column part. We create an empty array. We append we append every value of the column going downwards into this array. Then we convert it to a tuple. Then we check whether this value exists in the map or not, whether this key exists in the map or not, because this becomes a key here basically, right? We're using the row values and column values as a key here. If it exists, we directly take the the value of the uh, key from the row, this map, and increment the count. Which means if there is two count of particular row, it says that the row appears two times, and even if the column appears of the same type one time, it has to be counted two times. Fine. So then we return the count. Now the time complexity is O of n square. Why? This takes O of n plus iterating through the complete row takes another n. So this becomes O of n square. Fine. And here, since we are iterating I and j, you can see, so it becomes O of n square again. Fine. That's why O of n square plus O of n square, it becomes 2 of n square. So at the end, it becomes O of n square. Now space complexity is nearly O of n, because why nearly O of n? I said, suppose if you have all the rows as unique, fine, then the size of the map or dictionary would be same as the size of the n. But if you have multiple values of if you have multiple values similar, right? These three rows are similar, these two rows are similar, fine. So in the map, you will only have two, like one here and one here, two rows, right? That's why I said complexity would be nearly of O of n. In worst case, it will be O of n, and best case could be less than n. Fine. I hope you understood the code. Now let's move to the next slide. Now, since you have the understanding of the code, let's look at the dry run of the example. So first what we were doing, we were iterating I to n. This is basically row. Then here we will converting the array list into tuple. We will going from grid of I to n. Fine. As you can see here. So we took this complete row and we stored it into the dictionary 3, 1, 2, 2. Fine. And since it's the first value in the dictionary, we keep the count as 1. Again, we come to this row. We store 1, 4, 4, 5. 1, 4, 4, 5. First time, so count is 1. 2, 4, 2, 2. 2, 4, 2, 2. First time, so count is 1. Fine. Again, we encounter 2, 4, 2, 2. So we increment the count and it becomes 2. Right? So this is our dictionary. Great. Now we iterate from j till n, and we create an array. Then we again go from I to n. Fine. This is the second for loop which we were doing. Fine. If you can remember, This is the second for loop which we are doing for iterating the column values itself. So what we were doing, we were just creating for j to n. When we created a list, then we went from I to n. We were appending, let it be array. We were appending into array dot append I j, right? Since right now, if it is 0, it goes from 1 to n first, right? So we store this complete value into this array. Then we convert it to a tuple, right? So it becomes 3, 1, 2, 2. Now we check if we have this value in the dictionary or not. Since you can see that it is present in the dictionary, our count becomes 1. Similarly, it goes from 1444 and it is not present in the dictionary. So we skip it. Then we get 2442. It is present in the dictionary with count of 2. So our count becomes 1 plus 2, 3. Fine. Again, it checks for the last column. It is not present in the dictionary. So we skip it. And at the end, we return 3 as the output. So this is a dry run, and it's a pretty simple question if you can keep in mind. I took a long time to explain it because there was a lot to understand from n cube to n square, but the question is pretty straightforward. If you have any doubt or confusion about the solution we arrived at and how we arrived at it, I would suggest going back and understanding the intuition, the approach, and the code. And after that, do a dry run by yourself on 2, 3 examples, and I'm pretty sure you will understand both the solution and the thought process behind it. Okay, now let's move to the next slide. Now, since we are familiar with the problem and solution, let's move to the lead code and code the solution. First, we will create map, which is basically dictionary. We will take the length of the grid. We'll also implement count variable. Now, first I will go through every rows. Fine. First, we will go through every row. So for I in range n, then I will take an array variable and convert it into a tuple grid of I to n. So this basically will do what? It will take the complete row value, this one. Fine. Now, if array is was in map already, so we incremented the count by 1. Else, if it was first time, so we just put the value and make the count as 1. Right? Now we iterate for the column. Please keep in mind how I'm writing the loops. Sometimes people get confused. Instead of writing J here, people write I and they get confused while iterating the column part. So please keep that in mind. For I in range and fine. Now what we are doing, we are setting the each value of the column grid of I, not J, I. Fine, I of I and J. Fine. Then array of key, we are making it as key, converting it to a tuple after the loop, and we're checking if this array key is in map or not. If it is, we increment the count by map of array of key values, and at the end we just return the count. Now let's submit the solution. If we got a runtime error, why? You can see I have forgot to give here equal sign. So our solution not accepted. Now let's finally submit the solution. We got successfully submitted. Now the code of the problem is available in my GitHub repository. You can find the link in the description. Thank you everyone.